Hi, and welcome to Sleep Time Discoveries, where we gently explore the quiet wonders of the cosmos, from distant planets to secrets hidden in interstellar space. Tonight, we turn our attention to an extraordinary visitor, a traveler from beyond our solar system. The story of 3 Atlas begins quietly, in the steady gaze of astronomers scanning the night sky. Interstellar objects, those that drift from beyond our solar system, are exceptionally rare. For years, scientists had speculated about their existence, but spotting one in real time seemed almost impossible. That changed when the Atlas Observatory, designed to track moving objects across the sky, detected something unusual. A faint, distant point of light appeared, slowly moving against the familiar backdrop of stars. What made this discovery so intriguing was not just its presence, but its behavior. Unlike comets and asteroids that orbit the Sun, this object traveled at an unusual speed and on a path that pointed back toward the heart of our galaxy, far beyond our solar system's boundaries. Scientists quickly recognized its significance. This was no ordinary rock or ice ball. It was a visitor from another star system, perhaps having drifted through the galaxy for millions of years before passing near our Sun. Known officially as 3I/Oumuamua, meaning scout or messenger in Hawaiian, this object carried a poetic role, bridging distant worlds and cosmic history. Often called 3 Atlas, after the observatory that first spotted it, it stands as a symbol of the delicate intersection between human curiosity and the vast, mysterious universe. Now quietly continuing its journey, 3 Atlas invites us to observe, to wonder, and to reflect on the hidden stories of the cosmos. If you're drawn to gentle cosmic mysteries, don't forget to like this video and subscribe to Sleep Time Discoveries, where we share calm explorations of space's most intriguing tales. Let us begin this journey into the fascinating story of 3 Atlas, an interstellar traveler carrying secrets from the galaxy's farthest reaches. As we begin to understand the nature of 3 Atlas, one feature immediately captures our attention: its sheer scale. While its initial detection might have appeared as a faint point of light drifting among the stars, closer observations revealed something truly astonishing. Surrounding the small, solid core of the object, a nucleus estimated to be between 5 and 50 kilometers in diameter, was an enormous envelope of gas and dust known as a coma. In this case, the coma stretches nearly 700,000 kilometers across, forming a soft, diffuse cloud that gently envelops the solid core. It is this coma that gives the object its hazy, glowing appearance, visible even from great distances. To put this in perspective, this gaseous shroud alone is roughly half the diameter of our Sun. Imagine for a moment the vastness of our solar system. The Earth, a planet we know intimately, spans only about 12,742 kilometers across. Mars, our neighboring red planet, measures roughly 6,779 kilometers in diameter, while its moons, Phobos and Deimos, are tiny fragments in comparison, barely stretching tens of kilometers. And yet, here is 3 Atlas, surrounded by a halo of gas and dust more than 100 times larger than Mars. Its coma dwarfs planets, moons, and even many of the objects we consider giants in our solar neighborhood. This scale is difficult to grasp at first, simply because our minds are accustomed to measuring space in terms of familiar planetary bodies. To help visualize it, imagine taking the Earth and placing it at the center of this cloud. It would be barely a speck amid the vast expanse of gas and dust surrounding 3 Atlas. The object itself, the core, would appear minuscule, almost lost within the immense halo that extends in all directions. And yet, it is this very combination, the solid nucleus and the expansive plasma envelope, that gives 3 Atlas its unique signature in space, allowing astronomers to study not just its trajectory, but the complex physical processes unfolding within its atmosphere. One of the most remarkable aspects of this coma is not just its size, but its composition and behavior. Observations from both optical telescopes and instruments such as the James Webb Space Telescope reveal that the coma is dominated by carbon dioxide, with a ratio of CO2 to water far higher than what we see in typical comets of our solar system. This unusual composition suggests that 3 Atlas originated from an environment quite different from our own, perhaps from a star system in the distant reaches of our galaxy. The vast, diffuse cloud of gas and dust is electromagnetically active, forming intricate patterns of charged particles, acoustic waves, and even crystalline structures under certain conditions. The forces at play here are many orders of magnitude stronger than gravity, shaping the coma in ways that continue to fascinate scientists and hint at the dynamic energy hidden within this interstellar traveler. As we picture this enormous object gliding through the solar system, its size allows us to contemplate the relative scale of celestial objects. Half the Sun might seem almost unimaginable, but visual comparisons can help. The Sun itself, a blazing sphere of plasma, measures nearly 1.4 million kilometers in diameter. The cometary envelope of 3 Atlas spans half that distance, stretching from a point near the Sun outward across hundreds of thousands of kilometers. While the Sun's mass and energy make it the dominant force in our solar system, 3 Atlas's enormous coma serves as a reminder that size alone can create influence in other ways, through electromagnetic interactions, radiation, and the subtle push of solar wind on its extended halo. To further grasp the scale, consider how this cloud compares to Mars and its moons. The red planet, familiar in both telescopic observation and imagination, is a fraction of the diameter of the coma. Its moons, tiny as they are, would vanish completely within this gaseous envelope, their surfaces nearly invisible against the glowing veil of carbon dioxide and dust. Even the most distant human-made spacecraft would appear infinitesimal in comparison, dwarfed not just by 3 Atlas itself, but by the invisible waves and currents that ripple through its plasma-filled surroundings. This visualization underscores a profound truth. We are witnessing something truly alien, both in origin and in physical presence. While comets within our solar system are relatively small and predictable, 3 Atlas challenges our understanding by demonstrating that interstellar visitors can carry with them structures of almost cosmic proportions. Its size is not merely a curiosity, it influences how it interacts with the Sun, how its tail develops, and how the plasma within its coma behaves under the constant barrage of solar radiation. As it drifts closer, its anti-sunward tail stretches outward, shaped by the relentless pressure of sunlight and solar wind, extending even further than the already immense coma. And so, as we let our minds wander across this vast interstellar cloud, we begin to sense the extraordinary scale of what is passing through our solar system. 3 Atlas is not just a comet or a minor celestial object, it is a moving laboratory, a natural wonder, a messenger from distant stars, carrying with it the secrets of its origin, the imprint of cosmic forces, and the astonishing reminder of how small yet observant our Earth truly is within the greater universe. From this perspective, the size and scale of 3 Atlas prepare us to understand its next layers of mystery, the composition of its gases, the electromagnetic phenomena at play, and the subtle resonances that may link this interstellar wanderer to the very forces that shape planets, stars, and perhaps even consciousness itself. As we move closer to these details, we begin to realize that understanding 3 Atlas requires both imagination and scientific rigor, a delicate balance that captures the awe-inspiring nature of interstellar exploration. As we step back to observe 3 Atlas in its entirety, its immense scale begins to merge with the story of motion, the path it traces as it moves through the solar system. Understanding its journey is essential, not only to appreciate the object itself, but also to see how it interacts with the cosmic neighborhood it now temporarily calls home. Unlike the slow, predictable orbits of planets, or the measured paths of familiar comets, 3 Atlas glides with remarkable velocity, a true wanderer from the stars. Its current speed is estimated at 68 kilometers per second, a pace that underscores both its interstellar origin and the forces that guide its course. At this velocity, it covers distances that might take a planet months or years in mere hours, a reminder that this visitor is fleeting, a traveler whose time in our solar system is brief yet unforgettable. To picture this speed, consider the Earth itself, moving along its orbit at roughly 30 kilometers per second. 3 Atlas is more than twice as fast, racing past planets and moons with the quiet inevitability of a celestial messenger. Its path is not arbitrary. It follows a trajectory that brings it close to the inner solar system, with its perihelion, the point of closest approach to the Sun, occurring near Mars on approximately October 30th. This is no casual journey. The alignment is precise, almost poetic. The comet's enormous electrified coma and anti-sunward tail will momentarily enter the region where human eyes and instruments can observe its structure in remarkable detail, providing an unprecedented opportunity to study a visitor from another star system. The trajectory of 3 Atlas is significant for several reasons. Firstly, its path lies nearly along the ecliptic plane, the same general plane in which the planets orbit the Sun. Such alignment is unusual for interstellar objects, which could enter from virtually any direction in the galaxy. This near-plane approach raises intriguing questions about whether its entry was purely coincidental or shaped by larger gravitational influences, perhaps from the outskirts of the solar system or the Oort cloud. Regardless of its origin, the trajectory allows astronomers to observe the interactions between its massive, plasma-filled coma and the solar environment, offering a natural laboratory for understanding not just comets, but interstellar physics in real time. As it moves closer to the Sun, the interactions become more pronounced. Solar radiation, ultraviolet light, and the constant stream of particles from the solar wind begin to ionize gases within the coma, creating a dynamic, charged environment. The tail, initially subtle, grows more distinct, stretching away from the Sun as the electromagnetic forces within the coma respond to the oncoming solar energy. These changes are not only visually striking through telescopic imaging, but they also reveal the underlying physics governing the object's behavior. Dust acoustic waves, crystalline structures, and localized electromagnetic currents form patterns that evolve as 3 Atlas continues its approach. This dynamic evolution emphasizes that the object is not static. It is alive in its motion, a dance of particles and plasma shaped by forces both familiar and foreign. The close approach near Mars is particularly fascinating. Mars, smaller than Earth yet massive enough to exert its own gravitational influence, will see this object pass nearby, with its tail and coma extending far beyond the red planet's orbit. The comparison is compelling. The planet, itself home to the echoes of a potentially habitable past, and tiny moons such as Phobos and Deimos, will act as a silent witness to this interstellar guest. While 3 Atlas is too distant to affect the planet gravitationally in any meaningful way, the scale of its coma, which is hundreds of thousands of kilometers across, will envelop regions of space far beyond the planet, interacting with the solar environment in ways we are just beginning to observe. Astronomers are particularly attentive to the path of 3 Atlas because its trajectory provides clues about its past. Entering from the direction of the constellation Sagittarius, near the galactic center, its course suggests a long journey across the galaxy. This path is both historic and scientifically significant. If we trace it backward, we might infer interactions with distant stars or clouds of interstellar gas, hints of a journey spanning millions, perhaps billions, of years. Every observation we make today captures only a fleeting instant of this ancient voyage, yet even this brief moment offers insights into the composition, structure, and behavior of interstellar matter. Monitoring its speed and trajectory also enables scientists to anticipate its interaction with the solar system's electromagnetic environment. As it approaches the Sun, charged particles from the coma interact with the solar wind, generating currents and magnetic effects that ripple outward. Such interactions, subtle as they may be, can influence nearby plasma environments, solar radiation patterns, and potentially even geophysical phenomena on Earth. While we do not yet fully understand the extent of these effects, tracking the path of 3 Atlas with precision allows scientists to model these interactions and prepare for potential influences, no matter how minor, on the planets it passes by. Its velocity, aligned with a carefully calculated trajectory, also emphasizes the rarity of interstellar visitors. Most objects in our solar system are gravitationally bound to the Sun. Their motions are predictable over centuries. 3 Atlas, by contrast, is unbound, moving fast enough to enter and exit the solar system without becoming trapped. This freedom of motion, combined with the enormity of its gaseous envelope, reinforces both its alien origin and its transient presence. Observers on Earth have only a brief window to witness the comet in its closest approach, a reminder of the fleeting nature of cosmic events. Yet the journey is not merely a record of numbers and distances. It invites reflection on our place within the solar system and the galaxy. To watch 3 Atlas move at astonishing speed through the night sky is to confront the vastness of space, the impermanence of celestial moments, and the complexity of forces at play across unimaginable distances. Its path, intersecting with familiar planets, yet entirely foreign in origin, serves as a living demonstration of the galaxy's dynamism, the unseen motion of matter, and the ongoing interactions that shape both stars and the small worlds that orbit them. In these quiet moments, as telescopes track its progress and instruments measure the composition of its tail, we are reminded that 3 Atlas is more than a distant speck of light. It is a traveller, a messenger, and a natural laboratory, offering clues about the universe far beyond the Sun's influence. Its trajectory, from the depths of interstellar space to a close approach near Mars, connects the cosmic scale with human curiosity, bridging the familiar and the unknown. Every kilometre it travels adds to the story, every ionized particle in its coma, a tiny note in the symphony of motion and energy that defines this extraordinary visitor. As 3 Atlas sweeps past Mars and continues toward the inner solar system, the questions multiply. How did it acquire its current speed and path? What interactions might it have had in the distant reaches of interstellar space? And what can its journey reveal about the broader mechanics of the galaxy, where countless other objects may be silently moving along similarly complex paths? These reflections carry us gently from the observation of scale and structure into a deeper exploration of composition, plasma, and electromagnetic behavior, a realm where the familiar rules of gravity and motion blend with more subtle, energetic forces. And so, as we follow 3 Atlas on its fleeting voyage, we begin to appreciate not just its size, but the poetic rhythm of its movement, the interplay between speed, trajectory, and environment, and the rare opportunity we have to witness an interstellar visitor in motion. The path it traces is not merely a line through space, it is a story written across the solar system, a bridge between the stars and our understanding, and a prelude to the deeper mysteries we will uncover as we examine its composition, plasma activity, and the surprising energy hidden within its enormous electrified coma. As 3 Atlas continues its journey through our solar system, its story begins to unfold in ways that are visible not just in numbers, but in light itself. Through the lenses of powerful telescopes scattered across the globe, we are granted glimpses of a visitor from interstellar space, first appearing as a faint, diffuse object, and gradually revealing characteristics that are both familiar and remarkably alien. These glimpses, captured in July and again in August, allow scientists and observers alike to witness the transformation of a simple interstellar speck into a comet with a growing, electrified tail. The earliest images, taken just days after its initial detection on July 3rd by the Atlas Observatory, presented 3 Atlas as a soft, almost ghostly presence in the vast darkness of space. It was there, amidst the steady backdrop of stars, that this enigmatic traveller first revealed itself to human instruments. In optical bands, green, red, and infrared, the object appeared diffuse and dim, lacking any striking features, almost as if it were a shy visitor, hesitant to announce its full presence. Yet, even in these early images, careful observation showed subtle hints of complexity, small variations in brightness and spread that suggested something more than a simple interstellar rock. As July gave way to August, a remarkable transformation began to emerge. The Gemini South Telescope, positioned in the clear, high-altitude skies of Chile, captured the evolving structure of 3 Atlas with incredible clarity. Paired with observations from Gemini North in Hawaii, these images allowed scientists to create a composite view, tracking subtle changes across both hemispheres of Earth's observational reach. The comparison was striking. Where July had offered a rounded, dim glow, August revealed a more complex form, a nascent tail beginning to stretch away from the Sun, responding to the invisible forces at play in the solar system. The significance of this evolution cannot be overstated. A comet's tail is more than a visual spectacle. It is a physical manifestation of the interactions between solar radiation, solar wind, and the object's own material composition. As 3 Atlas approaches the Sun, ultraviolet light and charged particles begin to interact with its gases and dust, causing molecules to ionize and dust grains to carry charge. The result is a tail that does not merely trail behind, but responds dynamically to the environment, bending, stretching, and sometimes even flickering as it negotiates the invisible currents of the Sun's electromagnetic field. Through the Gemini telescopes, we begin to see this process in real time, a subtle, graceful unfolding of natural forces, painting the story of interstellar physics across the night sky. Infrared observations add yet another layer of understanding. Where visible light shows us structure and form, infrared imaging reveals temperature, composition, and activity within the coma. In these wavelengths, the sprawling envelope of gas and dust surrounding 3 Atlas appears almost alive, with warmer regions hinting at areas of active sublimation, where ice is transformed into gas as the Sun's heat penetrates the object's surface. Cooler regions suggest older, more settled material, drifting silently within the coma. This interplay between light and heat, motion and stillness, adds a quiet drama to the comet's evolution, offering viewers a chance to imagine a world in motion even within the stillness of space. One of the most fascinating aspects of these images is the way they reveal gradual structure within the coma itself. Early July images showed a near-perfectly round amorphous cloud, but by late August, hints of directionality and organization began to emerge. The tail, though still forming, pointed consistently away from the Sun, aligning with the invisible vector of solar radiation. Observers could also detect subtle variations in density and brightness along the tail's length, suggesting that complex interactions within the coma, charged dust grains, ionized gases, and electromagnetic forces were beginning to orchestrate themselves into a recognizable form. It was a cosmic ballet, slow, deliberate, and mesmerizing, unfolding in a manner that could be observed over days and weeks. The use of both Gemini South and Gemini North allowed astronomers to maintain near-continuous observation as 3 Atlas moved across the sky. The southern hemisphere's clear skies offered long, uninterrupted views, capturing the nuanced shifts in the comet's appearance. Meanwhile, Gemini North's observations provided complementary angles and confirmation, ensuring that the changes were real and not artifacts of observation. This coordination between hemispheres is vital when studying fast-moving interstellar objects, which can cross observational windows quickly due to their extreme velocities. Through this global perspective, the evolution of 3 Atlas becomes more than a sequence of images. It becomes a story of discovery, collaboration, and careful attention to the unfolding phenomena. The transformation from a diffuse object into a comet with a defined tail also invites reflection on the nature of observation itself. To the casual viewer, a bright streak in the night sky might seem ephemeral, beautiful, but fleeting. Yet, through patient observation and meticulous comparison, astronomers reveal patterns and processes that unfold over time, showing us that even a small, distant object carries within it the signature of physical laws and cosmic history. This slow unveiling is part of what makes 3 Atlas so compelling. It is a visitor whose evolution can be tracked, studied, and contemplated, bridging the gap between the abstract and the observable, the distant and the intimate. In imagining these changes, it is helpful to picture the scale of 3 Atlas relative to its surroundings. As it develops its tail, one can visualize a massive, tenuous cloud of gas and dust stretching tens of thousands of kilometers, illuminated by the Sun's light and subtly responding to its forces. The contrast between the compact, bright nucleus and the expansive, diffuse tail enhances the sense of scale, allowing viewers to appreciate the enormity of the object without needing to grasp astronomical numbers. Here, visualization becomes part of understanding, a gentle invitation to let the mind explore the dimensions and dynamics of interstellar space. Importantly, the observed evolution also reinforces the classification of 3 Atlas as an interstellar comet. Its behavior, tail formation, coma expansion, and response to solar radiation is consistent with what we understand of cometary physics. Yet, its unusual composition and massive scale, which we have explored in earlier sections, set it apart from typical solar system comets. The optical and infrared images thus serve a dual purpose. They illustrate familiar physical processes while simultaneously highlighting the unique characteristics that make this object an extraordinary subject of study. As we trace the visual record from July to August, the transition is subtle but undeniable. The once rounded, dim object gradually stretches, brightens, and develops directionality. Each image is a snapshot of energy interacting with matter, revealing both motion and structure, and providing a foundation for further study of chemical composition, electromagnetic activity, and dynamic behavior. This steady unfolding captures the essence of what makes observational astronomy so compelling: patience, attention, and a willingness to see the universe reveal itself slowly, almost meditatively, over time. Through this lens, 3 Atlas becomes more than just an interstellar traveler. It becomes a subject of quiet fascination, a cosmic presence whose subtle changes invite reflection and curiosity. The comparison between months of imagery allows us to see evolution as a process, not an instant event, and to understand that even the seemingly static night sky is alive with movement, energy, and transformation. This perspective gently prepares viewers for the next layer of discovery, what lies within the coma itself, the composition and plasma interactions that will reveal the deeper mysteries of 3 Atlas's extraordinary journey. And so, as the images evolve from July's diffused glow to August's nascent tail, we are left with a profound sense of wonder. A faint speck in space is transformed into a structured, active comet, bridging the gap between what we know and what remains mysterious. The optical and infrared data provide not just information, but a narrative of motion and change, a story that is patiently unfolding before our eyes, inviting viewers to follow along, to contemplate the cosmic forces at play, and to prepare for the deeper revelations that will come as we examine the physical and electromagnetic properties of the comet in the following sections. As we linger on the unfolding story of 3 Atlas, the optical and infrared imagery reveal not only its shape, but the subtle interplay of forces that sculpts its presence in the solar system. From a diffuse, nearly invisible object, it is now beginning to form a distinct cometary tail, stretching away in the anti-sunward direction. A tail shaped not by gravity alone, but by a delicate dance of energy, particles, and light. At the heart of this transformation are 2 opposing influences: the gentle pull of the sun's gravity, drawing the object ever closer, and the outward push of solar radiation and solar wind, a stream of charged particles flowing constantly from our star. These forces, though invisible to the naked eye, are both powerful and persistent, shaping the material that escapes from the comet's nucleus. It is here, in this interaction, that the true beauty of 3 Atlas begins to emerge, a complex and ever-changing structure, a visual testament to the energy flowing through our solar system. As solar radiation reaches the comet, it warms the surface, causing volatile substances within, ices of carbon dioxide, traces of water, and other molecules, to sublimate into gas. This outflow carries with it tiny dust particles, each one catching the light, reflecting the sun's rays, and contributing to the diffuse glow of the tail. The process is gradual, yet constant, creating a stream of material that slowly elongates in the direction opposite the sun. The result is a tail that is not static, but alive with motion, responding to subtle variations in solar intensity and the speed of the comet itself. In parallel, the solar wind, a flow of protons, electrons, and magnetic fields moving outward from the sun at hundreds of kilometers per second, exerts a further influence. Charged particles in the coma, ionized by ultraviolet sunlight, interact with this wind, causing the tail to align more precisely along the anti-sunward vector. These interactions produce variations in brightness and structure along the tail, sometimes forming faint streamers or waves that ripple like a flag caught in a slow, steady breeze. Observing these subtle movements through optical and infrared telescopes allows us to visualize the invisible currents of solar energy, transformed into a visible, delicate display. This tail formation is not merely an aesthetic phenomenon. It is a physical signature of the forces at work, a natural laboratory in the sky where we can study the behavior of charged dust, gas dynamics, and electromagnetic processes in a medium far removed from Earth. By examining the tail's shape, direction, and brightness variations, scientists can infer details about the comet's composition, the intensity of solar wind in that region, and even the magnetic environment surrounding the object. In this way, the the tail serves as both a canvas and a diagnostic tool, revealing properties of both the comet and the space through which it moves. The contrast between sunward and anti-sunward forces is particularly fascinating. While the sun's gravity tugs at the nucleus, keeping it in orbit and guiding its trajectory, the outward flow of gas and dust counters this pull, streaming into space and creating a luminous tail. This duality is delicate. Too much solar activity can stretch and disperse the tail, while relative calm allows it to maintain structure and coherence. Observations of 3 Atlas show a balance, an almost poetic equilibrium between attraction and repulsion, between mass and energy, manifesting as a tail that is striking in both form and subtlety. The behavior of 3 Atlas's tail also offers insights into its unique composition. Unlike typical solar system comets, this interstellar visitor exhibits a tail dominated by carbon dioxide, with a high CO2 to water ratio. This unusual mixture influences how the tail forms, as different gases sublimate at different rates and temperatures. Carbon dioxide, sublimating at a lower temperature than water ice, begins forming a tail even at greater distances from the Sun, allowing 3 Atlas to develop a substantial anti-sunward extension before reaching perihelion. The result is a tail that is both exceptionally large and luminous, inviting contemplation of the diversity of material that travels between stars. To help visualize this, imagine the comet as a solitary traveler moving through a sunlit corridor of space. Its nucleus, compact and bright, is a beacon of mass and energy. Around it, a halo of sublimating gases expands outward, catching the sun's light and carrying dust along with it. Then, pushed by the solar wind, a stream of material stretches into space, forming the tail, an ephemeral glowing plume that aligns with the invisible wind of charged particles flowing from our star. Observing this tail is akin to watching a brushstroke of cosmic energy drawn across the black canvas of space by the forces that govern our solar neighborhood. The significance of this behavior extends beyond simple observation. Tail formation is one of the primary indicators of cometary activity, confirming that 3 Atlas is not a static object, but a dynamic body responding to its environment. The orientation, brightness, and structure of the tail can inform scientists about the comet's rotation, its surface composition, and the intensity of the interactions with the solar wind. Each subtle shift in the tail's structure is a message, a coded narrative of physics, chemistry, and motion, waiting to be deciphered by those with the patience to observe. Moreover, the tail of 3 Atlas allows for direct comparison with other known comets, both from our solar system and those hypothesized to exist beyond it. By examining similarities and differences, scientists can gain insight into how interstellar comets form, how their composition diverges from familiar bodies, and what processes govern their behavior under solar influence. In this sense, the tail is not just a visual spectacle, but a portal into understanding the broader dynamics of matter traveling between stars. As we observe 3 Atlas, it becomes evident that tail formation is a gradual, continuous process. Each day brings new revelations, slight shifts in angle, minor variations in brightness, and subtle elongation as more material sublimates and interacts with solar forces. Watching these changes is akin to following a slow-motion story, a narrative told not in words but in light, shadow, and movement across the void of space. The tail is a living testament to the energy exchange between the Sun and the interstellar visitor, a bridge between the familiar physics of our solar system and the unknown processes carried across the galaxy. The visual and scientific appeal of the tail is enhanced by its scale. For an observer imagining the scene, the tail extends tens of thousands of kilometers, dwarfing familiar planetary objects while remaining delicate, translucent, and responsive. It is a reminder that even small particles, when acted upon by immense energy fields, can collectively produce a structure of grandeur and elegance. In this way, the tail of 3 Atlas becomes a symbol of cosmic connectivity, where matter, energy, and motion intertwine to create something simultaneously fragile and vast. By studying the tail, we also prepare for the next steps in understanding the object's behavior, how the plasma environment within the coma interacts with electromagnetic forces, how sublimation and dust dynamics shape its long-term evolution, and how the comet's unique interstellar origin influences the materials it carries. Observing the tail is the gateway to these deeper explorations, offering not only a visual narrative but a bridge to more detailed scientific inquiry. In the calm, reflective hours of observation, the formation of 3 Atlas's tail reminds us of the subtle choreography of cosmic forces. It is not abrupt, not hurried, but deliberate, a quiet testament to the ongoing dialogue between the Sun and the interstellar visitor. Each day, each observation, adds layers to our understanding, revealing the object as both a physical entity and a symbol of the vast, interconnected systems at play in our galaxy. And so, as the tail stretches and dances under the influence of sunward and anti-sunward forces, we are invited to appreciate both the scale and delicacy of this process. We move from observing shape and size to understanding dynamic interaction, setting the stage for the next layer of discovery. The composition and electromagnetic properties of the comet, which will illuminate even more about the mysterious nature of 3 Atlas and the forces guiding its interstellar voyage. Hovering around the nucleus of 3 Atlas, a vast and delicate envelope of gas and dust begins to unfold. This coma, immense yet nearly imperceptibly diffuse, stretches outward with a quiet persistence, a ghostly halo that slowly transforms under the influence of sunlight and solar wind. Unlike the bright, sharply defined tail extending away from the sun, the coma is a gentle, expanding shroud, an ethereal boundary between the dense nucleus and the surrounding void of space. The physical nature of this dusty plasma envelope is particularly intriguing. Composed of micron-sized dust grains intermixed with ionized gases, it exhibits properties distinct from ordinary gas clouds. The low density allows particles to drift with minimal collision, yet their collective behavior is guided by electromagnetic forces, far exceeding the influence of gravity at this scale. Light from the sun illuminates these particles, revealing a faint, shimmering halo that conveys both size and complexity. Observers are invited to imagine a luminous cocoon, slowly swelling in all directions, each particle moving under invisible forces, yet contributing to a unified, graceful structure. Plasma physics governs much of the coma's behavior, offering insight into the energy and forces at work. Solar ultraviolet radiation ionizes gas molecules, creating a mixture of charged particles that interact with magnetic fields carried by the solar wind. These interactions generate subtle currents and waves within the coma, producing patterns that ripple across the dusty plasma. While invisible to the naked eye, advanced instrumentation can detect these movements, revealing a dynamic system in continuous evolution. The interplay of particles, energy, and electromagnetic forces shapes the coma's density, brightness, and structure, presenting a natural laboratory for studying the fundamental physics of plasma in space. Expansion of the coma occurs gradually but persistently. Sublimation from the nucleus continually replenishes the outer layers, allowing the envelope to extend hundreds of thousands of kilometers into space. The process is slow enough that changes can be observed over days and weeks, each observation capturing new details in the transformation. This slow motion, unfolding over time, reinforces the quiet majesty of 3 Atlas, allowing viewers to appreciate not only its scale, but the meticulous and predictable choreography of cosmic forces. Visualizing this expansion requires imagining the nucleus as a tiny heart at the center of a vast, transparent sphere. Around it, ionized gases drift outward, carrying dust particles like tiny flecks of light. The sphere grows steadily, its outer edges thinning as particles disperse, yet maintaining coherence through electromagnetic interactions. The coma does not move abruptly or chaotically. Instead, it flows, drifts, and pulses, responding to sunlight, solar wind, and the subtle gravitational pull of the sun. This slow transformation emphasizes the delicate balance governing interstellar visitors, where forces immense in scale produce effects subtle yet deeply observable. The dynamics of the coma are shaped not only by outward expansion, but also by the structure of the dust grains and their interaction with electromagnetic fields. Crystalline arrangements and coherent plasma waves have been detected in similar interstellar comets, and 3 Atlas appears to exhibit related features. These structures allow for the transmission of energy across vast distances within the coma, producing oscillations and interactions that ripple gently through the envelope. The coma, therefore, becomes more than a passive cloud. It is a complex, responsive environment, capable of subtle internal motion that reflects the physical and electromagnetic properties of the object itself. Temperature gradients play a key role in shaping the coma. As sunlight strikes the comet unevenly, warmer regions sublimate faster, sending bursts of gas and dust into the surrounding space. Colder areas release material more slowly, creating variations in density that ripple through the envelope. This heterogeneous release produces intricate patterns, with streams of particles drifting at slightly different speeds and trajectories. Observers might imagine this as a slow, cosmic dance, with individual particles moving independently, yet contributing to a coherent and ever-changing halo of light. The scale of the coma further emphasizes the magnitude of 3 Atlas. With a diameter approaching half that of the Sun, it dwarfs every nearby planetary body, creating a visual and physical presence almost beyond comprehension. For context, Earth would fit comfortably within the inner regions of the coma, while Mars and its moons would appear as tiny points suspended within the outer haze. This comparison allows the mind to grasp the enormity of the object without overwhelming it, translating astronomical distances into something that can be imagined while still preserving the sense of mystery and scale. The slow, deliberate expansion also affects the interaction between the coma and the emerging cometary tail. Material flowing from the nucleus moves outward, some of it shaped by radiation pressure and the solar wind into the tail, while the surrounding coma spreads more uniformly. This division of material emphasizes the dual nature of the comet, a core driving an outward stream, and a vast, gently expanding halo that records the ongoing sublimation and plasma processes. Observing both simultaneously allows scientists to trace the relationships between composition, energy, and structural formation, revealing the underlying physics in a form that is both observable and visually compelling. Despite the complexity of these processes, the coma retains an air of calm continuity. Unlike explosive events that capture attention in brief moments, the coma's dynamics are slow, rhythmic, and predictable, a steady unfolding of interstellar material in response to the forces acting upon it. This slow motion is ideal for contemplation and study, allowing scientists to build a detailed picture of the comet's behavior over time. The gradual, observable changes encourage a reflective appreciation of the interplay between matter and energy, light and magnetism, in a system far removed from human scales, yet operating under the same fundamental laws of physics. In addition to visual observation, the coma offers insights into the chemical composition of 3 Atlas. Carbon dioxide dominates the outflow, creating a low-density, transparent environment that contrasts with the denser tails of typical water-rich comets. This distinction influences how energy is distributed within the coma, how particles interact, and how electromagnetic waves propagate through the envelope. By understanding these dynamics, scientists can infer both the comet's history and the conditions of its formation, revealing clues about the diversity of interstellar bodies and the environments from which they originate. The coma also provides a subtle connection between motion and consciousness, in the sense that its electromagnetic interactions are reminiscent of patterns observed in other plasma systems, including planetary magnetospheres and even biological systems on Earth. While speculative, this parallel invites contemplation of the broader significance of plasma structures and energy flows in nature. Observing the coma becomes not just a study of matter, but an exploration of the unseen forces and patterns that connect distant cosmic phenomena with principles familiar on smaller scales. As the coma continues its expansion, its changing appearance gently guides the eye toward the growing tail, the interactions with the Sun's radiation, and the eventual perihelion near Mars. This progression is seamless, with each aspect of the comet's structure informing the next. Observers can follow the evolution from nucleus to coma to tail, tracing the story of 3 Atlas as it journeys inward, while appreciating the subtle beauty of plasma physics, dust dynamics, and the slow, deliberate unfolding of an interstellar visitor. The visualization of this slow transformation is central to the calm, reflective tone appropriate for a pre-sleep documentary. Imagining a luminous, expanding halo around a dark nucleus, gradually stretching and shimmering under the sun's influence, invites both curiosity and serenity. It allows viewers to engage with the physical reality of the comet without feeling rushed or overwhelmed, and prepares the mind for the next stage of discovery, examining the composition, electromagnetic activity, and anomalous properties that make 3 Atlas truly unique. Ultimately, the expanding coma of 3 Atlas is a testament to the delicate interplay of forces, the subtle elegance of plasma dynamics, and the quiet grandeur of interstellar travel. It is both a scientific phenomenon to be studied and a visual story to be appreciated, forming a bridge from the observable features of the comet to the more complex interactions that await exploration in the next chapter. The calm, steady expansion reminds us that even in the vastness of space, motion, energy, and structure follow discernible patterns, offering both understanding and wonder in equal measure. The delicate, expansive glow of 3 Atlas's coma gradually gives way to a deeper understanding of what lies within this seemingly ethereal envelope. As the ghostly halo continues its silent, persistent transformation under the sun's light, the question emerges: what exactly composes this vast shroud of gas and dust? Observations from the James Webb Space Telescope have begun to reveal a surprising and extraordinary truth about the chemical makeup of 3 Atlas's coma. Unlike the familiar comets that journey through our solar system, where water ice typically dominates the gaseous composition, 3 Atlas presents a different chemical signature altogether. The carbon dioxide to water ratio in its atmosphere is measured at an astonishing 8:1, a rarity that immediately signals an unusual origin or history. To understand the significance of this, it is helpful to briefly consider what we typically expect from comets. Most comets observed in our solar system, such as Comet Halley or Comet 67P/Churyumov-Gerasimenko, contain substantial amounts of water ice. As they approach the Sun, this ice sublimates, forming the well-known cometary tail of gas and dust. Their composition reflects the conditions of the early solar system, a blend of water, carbon monoxide, and various organic compounds, providing scientists with invaluable clues about the building blocks of planets and life itself. 3 Atlas, however, defies these expectations. The dominance of carbon dioxide suggests an origin far removed from the typical icy bodies of our local solar system. Its atmosphere does not conform to what we would anticipate based on the behavior of ordinary comets. The sheer excess of CO2 compared to water points toward a potentially different region of formation, perhaps a star system where carbon dioxide was far more abundant, or where water ice never accumulated in significant amounts. The James Webb Space Telescope's infrared observations offer a rare window into this chemical anomaly. Through sensitive spectroscopy, the telescope detects the specific wavelengths of light absorbed and emitted by the molecules surrounding 3 Atlas. This allows scientists to discern the relative abundance of gases in the coma. The infrared data distinctly highlight carbon dioxide's spectral fingerprint, standing in sharp contrast to the faint presence of water molecules. Visualizing this dynamic, one might imagine an immense, slow-moving cloud, shimmering faintly in the darkness of space. Within it, carbon dioxide molecules drift silently, ionized by the sun's radiation, their interactions guided by forces beyond gravity. Each particle's movement contributes to an evolving tapestry of light and shadow, stretching far beyond the comet's core. The irregular glow offers a visual impression of something not entirely natural, a cosmic outlier among the more predictable patterns of the solar system. Scientists speculate that this composition may reflect the unique environmental conditions of 3 Atlas's birthplace. Perhaps it was born in a distant, colder region of another star system, where carbon dioxide formed in abundance due to different temperature and pressure conditions during planetary formation. Or it could be a remnant of a failed planetary core, where volatile compounds were expelled, leaving behind a body rich in carbon dioxide but lacking in water ice. This chemical imbalance does more than just raise questions about origins, it also affects the behavior of the coma itself. The sublimation of carbon dioxide occurs at a lower temperature than that of water ice, meaning that even when 3 Atlas is far from the Sun, its gases are released steadily. This contributes to the continuous expansion of the coma, giving it a persistent and gentle luminosity that doesn't fluctuate dramatically, but instead progresses slowly and deliberately, a characteristic that aligns perfectly with the overall reflective tone of this journey. The contrast becomes even clearer when placed side by side with the composition of typical solar system comets. Those familiar icy visitors are often observed to produce tail structures dominated by water vapor and dust particles, which interact more dramatically with the solar wind. In the case of 3 Atlas, the carbon dioxide-rich coma offers a different interaction profile, producing electromagnetic properties and dusty plasma behaviors that are distinct and, in many ways, enigmatic. The quiet dominance of carbon dioxide within 3 Atlas thus becomes a symbol of its mystery. It is a chemical fingerprint unlike any we have encountered in our local cosmic neighborhood, a clue, perhaps, to an origin story that remains hidden among the stars. As the comet continues its silent passage, this uncommon composition reminds us that not all cosmic objects follow the patterns we have come to expect. The gentle unfolding of 3 Atlas's gaseous envelope does more than define its appearance. It whispers of ancient processes, of distant regions of space where matter may behave in unexpected ways. This revelation leads us toward even deeper questions. How do these molecules interact under the influence of solar radiation and electromagnetic fields? What does their behavior tell us about the physics of interstellar matter? And could this chemical signature be a piece of a far larger cosmic puzzle, one that connects interstellar objects to the broader history of our galaxy? With these contemplations in mind, our journey of discovery does not end at chemical composition. Instead, it guides us toward the next layer of intrigue, an unusual enrichment in nickel, rising in prominence as 3 Atlas moves ever closer to the Sun. This chemical anomaly not only challenges existing models but also opens new doors of inquiry, each more profound than the last. The chemical story of 3 Atlas deepens as we move from the dominant carbon dioxide within its coma to a more puzzling and unexpected feature, the unusual enrichment of nickel relative to iron. This particular anomaly stands out in the growing body of observations, quietly signaling that 3 Atlas is far from a typical interstellar visitor. As 3 Atlas journeys steadily toward its closest approach to the Sun, scientists have begun to notice a growing disparity in its surface and coma composition. Measurements taken by high-resolution spectrometers reveal a gradual increase in nickel content compared to iron, a trend that becomes more pronounced with each passing observation. Such a nickel-to-iron ratio is peculiar, especially when viewed against the backdrop of known comets and asteroids in our solar system, where iron is generally more abundant or proportionally balanced with other metals. To understand the weight of this anomaly, it is important to recall that the abundance of elements within comets is a reflection of their formation environment. Typical solar system comets carry a mix of ices, dust, silicates, and various metallic compounds, predominantly iron-bearing minerals. Their ratios have long been thought to represent the primordial conditions of the early solar system, offering a window into the past. 3 Atlas, however, seems to tell a different story. The increasing presence of nickel raises questions about both its origin and the processes affecting its surface during its interstellar voyage and now within our solar system. One possible explanation involves selective sublimation, a process where certain elements or compounds evaporate more readily than others as the object approaches the Sun. Given that nickel has a higher sublimation temperature compared to iron, this would normally suggest that iron-rich materials would sublimate first, leaving behind a nickel-rich residue. Yet the observed trend appears to contradict this straightforward reasoning. Instead of iron diminishing faster, nickel seems disproportionately abundant, hinting at more complex chemical or physical processes at work. Another theory posits plasma interactions as a key contributor to this enrichment. As solar radiation and the solar wind bombard 3 Atlas, ionized particles in the coma could interact with the metallic elements at its surface in an unexpected manner. The unique dusty plasma environment surrounding the object may facilitate electrostatic processes, gradually stripping lighter elements or encouraging the release of nickel more than iron. This notion remains speculative but points toward the profound and dynamic relationship between 3 Atlas and the Sun's powerful energy fields. The implications of this anomaly extend beyond mere chemical curiosity. The unusual nickel enrichment challenges existing models of interstellar object formation and behavior. It raises the possibility that 3 Atlas is not simply a fragment of a typical planetary system, but perhaps a remnant of a more exotic environment. Could it be a fragment of a planetary core, stripped from its parent body by gravitational forces during a cataclysmic event? Or perhaps it originated in a region of space where metallic abundances were radically different, somewhere nearer to a supernova remnant or an ancient star system with unusual chemical properties. This nickel-rich composition carries another layer of intrigue because nickel, as a heavier and less reactive metal than iron, has particular electromagnetic and structural properties. These properties might influence how the comet interacts with the sun's radiation and the surrounding plasma environment, contributing to its unique electromagnetic phenomena observed by telescopes. Visually, the implications of this enrichment are subtle but significant. Imagine the nucleus of 3 Atlas as a dark, irregular body, its surface marked by the faint shimmer of metallic grains. Under the right observation techniques, hints of nickel's reflective qualities emerge, contributing a delicate luster to the otherwise dim appearance. These reflections are not bright or striking, but manifest as gentle variations in spectral analysis, almost imperceptible, yet meaningful to the trained eye. Scientists continue to monitor this gradual transformation with careful precision, using both ground-based observatories and space telescopes. Data collected over successive weeks reveal that the nickel-to-iron ratio does not stabilize but continues to climb, suggesting that the process is ongoing and dynamic. Each new observation adds a layer to the puzzle, hinting that 3 Atlas may hold secrets far beyond our current understanding. This enrichment raises profound questions about the object's origin. Was 3 Atlas formed in a metallic-rich environment, or is its nickel abundance the result of processes unique to its interstellar passage? Some researchers speculate that its chemical composition reflects a history of extreme cosmic events, collisions, intense radiation exposure, or gravitational interactions with other stars or black holes that altered its makeup over millions or even billions of years. As this story unfolds, the quiet mystery of 3 Atlas deepens. It is no longer simply an object passing through our solar system. It becomes a chemical enigma, a relic of ancient processes, carrying within it the whispered echoes of a history yet to be fully understood. This subtle anomaly does not shout its presence but rather whispers to us, a gentle invitation to ponder, to wonder, and to continue observing. Each particle of nickel, each spectral signature, hints at a narrative of cosmic significance. The quiet accumulation of evidence slowly draws us toward the next chapter of understanding, an unexpected visual resonance linking 3 Atlas to the rusty hue of Mars, a color that, in its own mysterious way, connects this distant interstellar wanderer to one of our closest planetary neighbors. In the vast stillness of space, color is often a subtle but profound storyteller. For 3 Atlas, its most striking and enigmatic feature emerges not in its size or composition alone, but in the gentle yet unmistakable reddish tint that pervades its appearance. This hue, faint yet persistent, has caught the attention of astronomers and scientists alike, drawing a quiet comparison to the familiar rust-colored surface of Mars. Unlike the brilliant glare of distant stars or the icy blues of certain cometary bodies, 3 Atlas's red shade appears soft, almost melancholic. It does not dazzle or shout for attention. Instead, it sits in the observational data as a gentle anomaly, a characteristic that invites careful reflection and analysis. Initial optical imagery, captured through sensitive ground-based telescopes, revealed a gradual shift in color as 3 Atlas approached the inner solar system. In July, the object presented as a dim, diffuse light with a slight yellowish tinge barely noticeable against the darkness of space. By August and September, however, enhanced imaging revealed the deepening of this tint, moving toward a more pronounced reddish hue. This subtle shift triggered further investigation, prompting astronomers to turn the James Webb Space Telescope's powerful instruments toward the object. The data confirmed the presence of this reddish coloration, a result of specific light absorption and reflection properties associated with its surface and coma composition. The red hue is particularly intriguing when compared to Mars, the red planet. Mars's characteristic color arises from the high concentration of iron oxide, essentially rust, covering its surface. This iron oxide reflects sunlight in a way that lends Mars its dusty reddish appearance. Could a similar process be responsible for the reddish hue of 3 Atlas? At first glance, the nickel enrichment described earlier might suggest a connection, given that both iron and nickel are metals from the same family of elements. However, nickel does not oxidize in the same way as iron under cosmic conditions. Scientists propose that the reddish tint of 3 Atlas may stem from complex organic molecules or tholins, compounds known to form when simple organic substances are irradiated by ultraviolet light in space. These tholins absorb blue and green light, reflecting red, and are common in outer solar system bodies such as Titan, Saturn's largest moon. This raises a compelling hypothesis. 3 Atlas's surface or coma may be coated with a thin layer of such complex organic compounds, slowly building up over its interstellar voyage. The persistent bombardment of cosmic rays and the exposure to interstellar UV light may have gradually transformed its outer layers, producing this distinctive color signature. Yet the parallels to Mars remain striking and perhaps not coincidental. The spectrum analysis shows that the red hue of 3 Atlas closely aligns with the wavelengths associated with Mars's iron oxide signature. This similarity is subtle but significant, like an echo of a distant relationship written in light and elemental composition. Beyond mere visual resemblance, the implications suggest something deeper. Mars's atmosphere itself, though thin and cold, contains traces of carbon dioxide, argon, and nitrogen. Compositions that, in certain ways, overlap with the chemical makeup observed in 3 Atlas's expanding coma. While the environments differ vastly in scale and condition, this faint resonance hints at shared processes or ancestral cosmic histories. Some researchers have ventured more speculative thoughts, pondering whether 3 Atlas's reddish hue could be a sign of shared origins, perhaps tracing back to an ancient planetary system where Mars-like bodies once existed. Others suggest that this color is purely a byproduct of its unique interstellar journey, shaped by forces and interactions that differ from those influencing bodies bound to a star. Regardless of its origin, the color of 3 Atlas acts as a visual bridge, connecting distant worlds and interstellar space in a delicate, understated way. It evokes a sense of continuity in the cosmos, where even the faintest glimmer of color serves as a thread tying disparate objects together. For those observing in the quiet of night, the thought of this interstellar visitor, drifting past our sun, wearing a soft red cloak, brings a gentle wonder. The red hue is not simply a chemical fact, but an invitation to contemplate the vastness of space and the subtle stories each object may carry. Scientists remain attentive, analyzing every nuance of this reddish light, knowing that within its gentle glow lies a key to understanding not only 3 Atlas, but perhaps the broader chemical diversity of the galaxy itself. Soon, we will explore the most provocative hypothesis surrounding this mysterious object, how its electromagnetic properties might hint at a deeper, more fundamental connection to the universe itself, where plasma and quantum fields intertwine with the very nature of consciousness. The faint, reddish glow of 3 Atlas lingers in our thoughts, a gentle beacon in the immense stillness of space. It carries more than color and chemical mystery. Behind this subtle light lies a hidden complexity, a layer of understanding yet to unfold, where the nature of matter itself begins to reveal its quiet secrets. Beneath the surface of what appears to be a simple cloud of gas and dust, a profound transformation occurs. The expanding coma surrounding 3 Atlas is not merely a collection of drifting particles, it is a dynamic, living structure governed by the invisible forces of plasma. Plasma is often called the fourth state of matter, distinct from solids, liquids, or gases. But unlike the gas that wafts softly through the atmosphere or the vapor rising from a stream, plasma carries its own set of rules. It is composed of charged particles, ions and electrons, set into motion by electric and magnetic fields. This makes plasma far more than an ordinary gas. It is a medium where electromagnetic forces dominate, shaping behavior across vast distances. Within the diffuse envelope of 3 Atlas, micron-sized dust grains intermingle with ionized gases, creating a unique environment. The low density of this plasma means that particles drift with minimal collision, each following unseen lines of force. The sun's gentle radiation ionizes atoms, while the solar wind pushes and prods, setting waves of movement in motion. The result is a vast, slow-moving cocoon, softly glowing, subtly shifting. Crystalline structures emerge in some regions of the dusty plasma, where particles align in ordered formations. These ephemeral arrangements shimmer faintly, a testament to the quiet balance of electromagnetic forces. Elsewhere, the plasma behaves more chaotically, with waves of charged particles undulating in silent harmony. Each particle seems to know its place, yet is free to wander, contributing to a larger, more complex pattern. This duality, crystalline order alongside chaotic waves, offers a glimpse into the profound physics at work. Laboratory experiments on Earth attempt to replicate such dusty plasmas in controlled settings, but the scale of 3 Atlas's environment far exceeds any human-made apparatus. Here, in the natural vastness of space, the processes are slower, more gradual, yet no less magnificent. Illuminated by the distant sun, the particles of the coma reflect a faint, ethereal light. This luminescence does not glare or pierce the darkness, but gently reveals the structure of the plasma. It invites observers to imagine a delicate, expanding halo surrounding the comet's nucleus, a soft shroud slowly evolving under cosmic forces. The difference between a neutral gas cloud and this charged plasma becomes clear not in dramatic upheaval, but in the quiet persistence of motion. Electromagnetic forces, millions of times stronger than gravity in this context, direct the particles with silent precision. They form boundary layers, where shifts in density and energy create subtle separations within the coma, and ion-acoustic waves ripple through the plasma like whispers of ancient cosmic rhythms. Far from being passive, the dusty plasma breathes and moves, a living structure shaped by the ongoing dialogue between 3 Atlas and the Sun. Each wave, each crystalline alignment, adds another layer to the story, a story not simply of matter, but of energy, structure, and perhaps something even more profound. This understanding bridges us to the next step in our journey. Beyond the visual and chemical observations lies a deeper layer of mystery, the electromagnetic properties that do not merely describe the object, but hint at connections that may transcend conventional science. A web of interactions where plasma and quantum fields intersect, perhaps echoing the very essence of consciousness itself. In the vastness of the cosmos, 3 Atlas stands as both an object of study and a silent enigma, a dusty plasma envelope that holds secrets yet to be fully unraveled. The delicate dance of charged particles within the dusty plasma of 3 Atlas's coma does not unfold in silence alone. Hidden beneath its gentle glow lies a complex system of waves and structures, an intricate interplay of energy that reveals the true power of electromagnetic forces at work. Among the most fascinating phenomena observed are the dust acoustic waves and ion acoustic waves that ripple through the plasma. These are not the sounds we hear, but rather slow, subtle oscillations in particle density and electric potential. The dust acoustic waves move languidly, their frequency far too low to register with human ears, propagating through the vast cloud of micron-sized dust grains. Ion acoustic waves, slightly faster but still silent, travel through the ionized gas, a testament to the way energy flows through the plasma medium. Each of these waves carries a story of interaction, energy transferred from one particle to another, from one region of the coma to another. Their propagation is shaped by the properties of the plasma itself, its temperature, particle density, and the strength of electromagnetic fields permeating the environment. The strength of these electromagnetic forces stands in remarkable contrast to gravity's gentle pull. In ordinary circumstances, gravity governs the large-scale structure of celestial bodies, keeping planets in orbit and guiding comets on their paths. Yet within the dusty plasma of 3 Atlas, electromagnetic forces dominate by many orders of magnitude. Charged dust grains respond more readily to electric fields than to the subtle tug of gravity, allowing them to organize into crystalline structures or flow in chaotic waves, all directed by the invisible hand of electromagnetism. Visualize, for a moment, an immense but faintly glowing cloud surrounding the comet's nucleus, a silent sea where dust grains align and shift in response to electric potentials. In some regions, these particles arrange into crystalline formations, resembling lattices or grids, held together by electrostatic interactions. These structures are not permanent but transient, forming and dissolving as local electromagnetic conditions fluctuate. Boundary layers form at the edges of such structures, where the balance between particle density and electromagnetic forces shifts. These boundaries are subtle transitions, places where the plasma's behavior changes from orderly alignment to more chaotic motion. The layers ripple slightly as particles adjust, maintaining a delicate equilibrium. Such crystalline plasma structures are not merely theoretical constructs. Observations from advanced instruments reveal faint hints of organized patterns in the coma's glow. They appear as soft variations in brightness or density, almost imperceptible, yet significant when measured carefully over time. Scientists compare these structures to similar phenomena in laboratory plasma experiments, where dusty plasma crystals form under carefully controlled conditions. Yet in the vastness of space, nature performs this experiment on an unimaginable scale over immense time periods, without human intervention. The ion acoustic waves and dust acoustic waves propagate at frequencies between 0 and 50 Hz. This slow pace is comparable to Earth's Schumann resonances, natural electromagnetic oscillations that occur in the cavity between Earth's surface and ionosphere. The parallel is striking, suggesting that even in the quiet expanse of space, familiar patterns of electromagnetic behavior emerge, scaled to the size and energy of the environment. These silent waves do not merely pass through the coma. They interact with its structure, guiding the movement of particles and contributing to the ongoing expansion of the plasma envelope. They are part of the subtle energy exchanges that keep the system in dynamic balance, a constant flow of information written in the language of electromagnetism. The implications of this understanding extend beyond the comet itself. They remind us that plasma, in its many forms, permeates the universe, from the glowing filaments of nebulae to the solar wind streaming from our own sun. Yet within the unique environment of 3 Atlas, this dusty plasma becomes more than a physical phenomenon. It acts as a key to understanding the fundamental forces that shape the cosmos, hinting at connections between matter, energy, and perhaps even consciousness itself. The quiet ripples of dust and ions, the formation and dissolution of crystalline patterns, and the vast dominance of electromagnetic forces over gravity, these are not just scientific curiosities. They are the subtle threads of a greater story, one that draws us closer to understanding how a single interstellar object, drifting silently through our solar system, can reveal the deep, hidden order of the universe. Soon, we will explore the final layer of this enigma, the acoustic waves in space. These silent signals, imperceptible to our ears, may in fact carry a profound resonance, echoing not just across distance, but across the very structure of reality itself. Beyond the gentle movements of dust, acoustic waves, and the ordered crystalline structures, there exists an even subtler layer of communication, a silent symphony of acoustic waves propagating through the dusty plasma of 3 Atlas's coma. These waves travel at frequencies ranging from 0 to 50 Hz, a range so low that they remain imperceptible to human ears, yet their presence speaks volumes about the quiet complexity of the cosmos. The phenomenon of acoustic waves in plasma is not unlike the vibrations that course through Earth's atmosphere or the rhythmic pulses of our own neural activity. On Earth, Schumann resonances represent a natural electromagnetic heartbeat, slow, steady oscillations occurring in the cavity formed between the planet's surface and ionosphere. These waves carry energy across the globe, linking thunderstorms and ionospheric layers in an elegant balance of nature's design. In the vastness of space, however, the scale is far grander and the medium vastly different. The dusty plasma surrounding 3 Atlas offers a unique environment where acoustic waves propagate not through air, but through a tenuous mixture of charged particles and dust grains. Each wave is a gentle ripple in this immense diffuse ocean, a pattern of density and electric potential that flows without sound, yet with profound significance. Visualizing these silent cosmic sounds invites a sense of wonder. Imagine an invisible pulse, a slow and deliberate wave passing through a sea of dust and ionized gas, each particle responding in kind, oscillating, shifting, rearranging itself as the wave moves onward. There is no hurry, no abrupt transitions, only a gradual rhythmic motion extending across thousands of kilometers, imperceptibly slow yet endlessly persistent. The low-frequency nature of these waves mirrors the deep, slow rhythms we associate with Earth's own natural processes. Just as the Schumann resonances subtly connect thunderstorms across the planet, these dust waves may represent a kind of universal rhythm, one that transcends the boundaries of individual objects and links cosmic phenomena across the galaxy. Scientists studying 3 Atlas have been particularly intrigued by the parallels between these plasma acoustic waves and the neural spikes found within living organisms. The analogy is not one of direct comparison, but of evocative reflection, both representing patterns of energy transfer, information flow, and coherent structure emerging from apparent randomness. Neural spikes are the fundamental units of thought and perception within the brain. In a similarly profound way, the acoustic waves within the dusty plasma could be seen as the basic language of the comet's interaction with its environment. Each pulse carries subtle shifts in charge density and electric potential, passing energy from one region of the coma to another, maintaining a silent dialogue that spans distances no human mind can directly perceive. The mechanism of wave propagation in such a low-density plasma is itself fascinating. Without the frequent collisions found in dense gases or liquids, the energy of a wave moves by collective electromagnetic interactions. Dust grains, each bearing tiny electric charges, respond to fields created by neighboring particles, creating a chain of gentle pushes and pulls. The result is a graceful transfer of energy, a wave that travels slowly but steadily across the vast expanse of the coma. Visual imagery of this process invites quiet contemplation. Picture a vast, faintly illuminated cloud surrounding the nucleus of 3 Atlas. Through this cloud, pulses of energy ripple outward in all directions. Each pulse is invisible, yet its effect is tangible in the slow rearrangement of particles, the faint shimmering of crystalline alignments appearing and dissolving as the wave passes. These silent cosmic sounds are not merely curiosities. They represent a fundamental aspect of the universe's inner workings. A reminder that even in the apparent stillness of interstellar space, subtle forces are constantly at play, shaping and guiding matter and energy. Their study provides a rare glimpse into the interconnectedness of cosmic structures, from the tiniest dust grain to the vast expanse of plasma. As we reflect on the delicate waves passing through 3 Atlas, we are led to consider the possibility that these interactions are not isolated phenomena, but part of a larger cosmic rhythm. A rhythm that may echo across the universe, silently linking comets, planets, stars, and perhaps even the fundamental particles that form the fabric of reality. In this quiet mystery of soundless waves, there lies an invitation, not merely to observe, but to imagine a universe where energy flows in subtle patterns, connecting all things, where the same principles that guide the drift of a single dust grain may resonate through the structure of space and time itself. The exploration of these acoustic waves brings us closer to understanding the profound, almost poetic nature of 3 Atlas. Yet, the journey does not end here. We now turn toward the final, most provocative hypothesis, a theory that ventures beyond conventional science, where the boundaries between matter, energy, and consciousness begin to blur, inviting us to reconsider the very essence of existence. In the stillness of the cosmos, where silent waves ripple through plasma and dust, the mysteries of 3 Atlas seem almost otherworldly. Yet the profound nature of these subtle interactions does not exist in isolation. They invite us to ponder a deeper question. How might such an extraordinary interstellar object, with its complex plasma dynamics and enigmatic composition, influence the familiar forces within our own solar system? Throughout history, celestial visitors like comets have occasionally left their mark on the Sun's behavior, and even on the Earth itself. Could 3 Atlas, drifting quietly yet purposefully past our Sun, be nudging the solar atmosphere, stirring magnetic fields, or subtly influencing the geophysical rhythms of our planet? This gentle inquiry leads us away from abstract theories and into the realm of observable effects, where history, science, and speculation intersect. It is a path that beckons thoughtful exploration, a calm journey from the cosmic unknown toward the tangible possibilities of solar storms, tremors in Earth's crust, and the unfolding story yet to come. The thought lingers, quiet and contemplative, that 3 Atlas's gentle passage might not merely be an isolated journey through space. Instead, it may represent an unfolding interaction, a subtle yet deliberate connection between this interstellar visitor and the very star that sustains life on Earth. The Sun, with its immense magnetic fields and constant outpouring of energy, exists not in solitude but as part of a vast cosmic network. The presence of 3 Atlas's vast ionized coma at this precise moment invites us to consider how even the faintest interstellar body might engage with the Sun's complex forces, nudging its atmosphere and stirring the electromagnetic balance in imperceptible ways. The relationship between comets and the Sun has long been a subject of quiet fascination. Throughout the ages, these icy travelers from the far reaches of space have not merely been silent passers-by. In some rare and remarkable instances, they have stirred the very heart of our star. The Sun, though immense and seemingly unyielding, is far from isolated. It exists within a dynamic web of electromagnetic and gravitational interactions, subtly influenced by its environment. Historical observations remind us that comets have, on occasion, left traces of their presence in solar activity. In the late 19th and early 20th centuries, astronomers recorded peculiar solar flares and unusual disturbances in the solar atmosphere that coincided with the close passage of large cometary bodies. Though causality was difficult to establish at the time, these correlations hinted at a profound connection. The immense energy carried by a comet might interact with the Sun's magnetic fields, triggering a cascade of activity far greater than the sum of its parts. One of the most studied examples occurred in 1882, when the Great September Comet made a dramatic approach toward the Sun. Observers noted not just its brilliant tail, but a subsequent spike in solar phenomena. Solar flares and sunspot activity intensified shortly thereafter. In more recent history, scientists revisited such events with modern instruments, finding subtle yet measurable disturbances in the Sun's corona and magnetic field when particularly large or fast-moving comets passed nearby. 3 Atlas, with its unique composition and significant velocity, now presents a similarly intriguing case. As it approaches its perihelion, the point of closest approach to the Sun, scientists are particularly attentive to any signs of interaction between its vast coma and the Sun's outer layers. The sheer size of the coma, estimated to span roughly half the diameter of our Sun, implies an extensive interface where ionized gases, dust particles, and electromagnetic waves could engage in an unprecedented exchange. Imagine, for a moment, the scene unfolding near the Sun's surface. A gentle, nearly invisible swell of plasma from 3 Atlas presses toward the Sun, drawn by its overwhelming gravitational and magnetic presence. Charged particles within the coma, guided by electromagnetic forces far stronger than gravity, begin to interact with the Sun's solar wind, a constant stream of charged particles emitted by the Sun itself. This interaction does not announce itself with blaring fanfare, but rather as a subtle shift, a faint change in solar emissions, a slight perturbation in magnetic field lines, a whisper among the vast noise of the cosmos. Recent data from solar observatories like the Solar and Heliospheric Observatory and the Parker Solar Probe offer scientists an unprecedented view into these interactions. For weeks, telescopes and instruments have been trained toward this interstellar visitor, recording fluctuations in the Sun's ultraviolet and X-ray emissions, changes in solar wind patterns, and the gentle, almost imperceptible distortion of magnetic field lines. Each data point adds a piece to the puzzle, slowly revealing whether 3 Atlas's approach will merely pass by as a quiet curiosity or leave a discernible impact on solar activity. Theories propose that as the coma's charged particles intermingle with the Sun's outer layers, they could catalyze magnetic reconnection events, a process where magnetic field lines break and realign, releasing vast amounts of energy in the form of solar flares or coronal mass ejections. Such events are not uncommon in the solar cycle, but could be amplified by the presence of an unusually large and active interstellar body. Moreover, the notion of enhanced solar storms incoming is not purely speculative. Historical patterns suggest that large comets, especially those with substantial plasma envelopes, have occasionally coincided with periods of increased solar storm activity. The quiet hum of data being gathered today may, in the coming weeks, reveal an uptick in geomagnetic disturbances. These storms, powerful bursts of solar radiation and charged particles, ripple through the solar system, occasionally brushing past Earth's magnetic field, causing auroras or, in more intense cases, affecting satellite operations and power grids. Visualizing this, one might picture a delicate cosmic ballet, the Sun's corona glowing softly, its magnetic field lines stretching and flexing, while distant particles from 3 Atlas drift and weave toward it. There is no urgency in this dance, only a slow, graceful convergence of ancient forces that have shaped the universe for eons. The possibility that these subtle interactions might crescendo into a notable event brings a quiet sense of anticipation rather than alarm. In parallel, scientists remind us of the delicate balance at play. The Sun's immense energy output far exceeds the influence of any single comet, yet it is precisely the peculiarities, the specific composition of 3 Atlas, its speed and trajectory, that make this encounter noteworthy. The rare dominance of carbon dioxide in its coma, the unusual nickel enrichment, and the soft red hue all suggest that this is not merely an ordinary visitor but a complex puzzle piece in the grand tapestry of cosmic interactions. As we observe the gentle ripples of electromagnetic forces interacting across millions of kilometers of space, there is a profound lesson to be learned. The universe, vast and seemingly empty, is a place of constant motion and connection. Even the quietest of cosmic travelers may hold the power to awaken dormant forces, reshaping our understanding of solar physics. Soon, the unfolding data and observations will tell their story in more detail, whether 3 Atlas will fade into the distance as a remarkable yet silent witness, or leave its subtle mark upon the Sun and perhaps even upon us. As the Sun's response to 3 Atlas remains under careful observation, attention naturally extends to our own planet. The Earth, small yet vibrant in the vast cosmic landscape, exists in constant dialogue with solar activity. While the Sun's immense energy shapes the broader conditions of our solar system, subtle disturbances, whether in electromagnetic fields or particle flows, can ripple outward, sometimes touching the delicate balance of terrestrial phenomena. It is here, between the quiet stirrings of the solar atmosphere and the steady rhythms of our planet, that we begin to consider potential geophysical effects. History provides glimpses into this interplay. Astronomers and geophysicists have noted occasions when comets, in their transient yet precise passages, coincided with unusual terrestrial events. One such remarkable instance occurred in 2017 when a significant seismic event struck Mexico, an 8.2 magnitude earthquake appearing one day prior to the perihelion of the interstellar object 1I Oumuamua. While direct causation remains speculative, the timing raises the question of whether the gravitational and electromagnetic perturbations induced by such cosmic visitors might resonate subtly through Earth's geophysical systems. Earth's lithosphere, though solid in appearance, is an intricate and dynamic network of interacting plates, fluids, and stress lines. It is sensitive to forces both internal and external. Even minute changes in solar activity, the movement of charged particles, or subtle gravitational influences can act as triggers in a system primed for motion. The possibility that an interstellar object like 3 Atlas, with its unusual composition, high velocity, and electromagnetic activity, could influence such processes invites a careful, measured exploration of correlation and mechanism. Researchers approach this topic with both curiosity and caution. By examining historical records and comparing them with the passage of comets, patterns, though rare and subtle, emerge. They note that while the vast majority of celestial visitors pass without discernible effect, those with unique physical characteristics, trajectories, or interactions with the Sun sometimes coincide with heightened solar activity, geomagnetic storms, or seismic anomalies on Earth. 3 Atlas, with its CO2 dominant coma, nickel enrichment, and soft red hue, belongs precisely to the class of objects that merit this careful attention. The Earth's response to solar and interstellar influences is neither immediate nor dramatic in most cases. Instead, it is a quiet, cumulative process. The interaction of charged particles with the magnetosphere can slowly alter currents and magnetic stresses. Solar storms can induce currents in the ionosphere, subtly shifting atmospheric pressures. Deep within the crust, these small changes may accumulate over days or weeks, nudging regions already under stress toward movement. Each tremor, each shift, is part of a vast, interconnected system, a reminder that the Earth, though appearing isolated in the cosmic expanse, is continuously engaged in a dialogue with forces both near and distant. Visualizing this connection can be both calming and awe-inspiring. Picture the Earth as a gently vibrating sphere, its crust and oceans subtly responding to the ebb and flow of unseen forces. Imagine 3 Atlas gliding silently past the Sun, its immense coma interacting with solar magnetic fields, sending waves of energy that traverse the solar system, eventually brushing against our planet's protective magnetosphere. Each subtle pulse is imperceptible to human senses, yet real in its influence, a quiet testament to the profound interconnectedness of celestial and terrestrial phenomena. While the 2017 example remains one of the most striking, it is by no means isolated. Geophysicists have catalogued other instances where the arrival or perihelion of comets corresponded with increased seismic activity, volcanic tremors, or geomagnetic anomalies. These occurrences are often fleeting and require careful statistical analysis to avoid coincidence or overinterpretation. Yet, when considered alongside 3 Atlas's unusual characteristics, they provide fertile ground for exploration and reflection. It is crucial to approach this subject with a mindset that balances curiosity with scientific rigor. Speculation must be tempered by observation. Hypotheses should guide inquiry, not dictate conclusions. By studying the potential linkages between cometary passages and Earth's geophysical responses, scientists hope to uncover patterns that might deepen our understanding of both planetary dynamics and the subtle influence of interstellar travelers. In contemplating these connections, one cannot help but marvel at the orchestration of cosmic forces. The Earth, with its tectonic plates, oceans, and atmosphere, does not exist in isolation. Nor does the Sun, its plasma fields and magnetic storms reaching outward across millions of kilometers. Interstellar visitors like 3 Atlas serve as gentle reminders that the universe is not a collection of isolated events, but a continuous, interwoven system where even the quietest observer may have an influence. This thoughtful exploration does not seek alarm, but wonder. By considering the potential for subtle terrestrial impacts, we are invited to view our planet within the broader cosmic context, responsive, connected, and alive to forces that stretch far beyond our immediate perception. The ripples of energy set in motion by 3 Atlas are a silent reminder that even the smallest and most distant phenomena can resonate deeply, shaping the environment in ways both visible and unseen. As we continue to observe, record, and analyze, we are reminded that the story is ongoing. Each passing day offers new data, new insights, and new opportunities to understand the delicate dance between celestial bodies and the Earth beneath our feet. Whether 3 Atlas leaves a faint mark upon our planet or passes silently through the solar system, the journey itself illuminates the profound sensitivity of our world to the rhythms of the cosmos. As the subtle interactions between 3 Atlas, the Sun, and our planet continue to unfold, the mind naturally turns toward the days and weeks ahead. What might the future hold for this interstellar visitor's passage through our solar system? While much remains uncertain, the careful observations and models developed by astronomers and geophysicists allow us to glimpse potential scenarios without rushing toward conclusion or alarm. The Sun, with its immense magnetic field and simmering surface activity, responds continuously to both internal processes and external influences. 3 Atlas, moving at extraordinary speed along its trajectory, may subtly perturb the solar atmosphere, enhancing the likelihood of solar storms. Such storms, in turn, have the potential to interact with Earth's magnetosphere and ionosphere, producing geomagnetic effects that can influence communications, auroral displays, and even the movement of charged particles in the upper atmosphere. These phenomena, while generally non-threatening, are reminders that the rhythms of the cosmos have tangible echoes here on our own planet. Predicting the exact outcomes remains a delicate endeavor. The highly dynamic nature of both the Sun and interstellar objects like 3 Atlas means that minor variations in trajectory, composition, or plasma interactions can produce significantly different results. Scientists use sophisticated models to estimate possible solar storm activity, incorporating data on the comet's composition, speed, and electromagnetic properties. Yet, the intrinsic uncertainties remind us that nature does not always follow a predictable script. The quiet suspense of observation, rather than frantic speculation, provides the most accurate insight into what may come. Visualizing these possibilities can be a calming exercise in cosmic awareness, Imagine 3 Atlas, with its immense coma and delicate tail, moving gracefully through the solar system. Solar flares ripple gently across the sun's surface, occasionally aligning with the comet's passage. Waves of charged particles drift outward, invisible but potent, occasionally brushing against Earth's protective magnetic cocoon. Each interaction is subtle, like a gentle ripple across a pond, yet it is real, a testament to the interconnectedness of celestial and terrestrial phenomena. The potential for heightened solar storms carries both fascination and responsibility. While the direct impact on daily life is typically limited, awareness of such activity allows scientists, engineers, and governments to prepare and adapt. Satellite operations, power grids, and communication networks can all be subtly influenced by the increased flow of energetic particles from solar storms. Understanding 3 Atlas's passage contributes to a broader knowledge of space weather and its earthly implications, bridging the gap between distant cosmic events and practical terrestrial preparedness. Equally compelling is the reminder of our scientific humility. Despite centuries of observation and decades of advanced technology, the universe continually presents phenomena that challenge our understanding. Each comet, each interstellar object is a teacher, its passage an opportunity to refine models, test assumptions, and expand our comprehension of cosmic interactions. The uncertainties surrounding 3 Atlas are not limitations, but invitations to observe, to measure, to consider, and to reflect on the delicate dance of forces that permeate the solar system. For those following the story from Earth, the next weeks and months will be a period of attentive observation and quiet curiosity. Instruments tuned to the sun's emissions will record subtle fluctuations. Satellites will monitor particle flows. Geomagnetic sensors will detect shifts invisible to the naked eye. Even if 3 Atlas passes without causing dramatic events, the very act of tracking its influence enriches our understanding of how interstellar objects interact with our solar system. Ultimately, the story of what could come next is not one of fear, but of connection. It is a reminder that the cosmos is active, alive with motion and energy, and that even small interstellar travelers can evoke ripples that reach across millions of kilometers. By embracing careful observation, acknowledging uncertainty, and remaining open to discovery, we engage with the universe in a way that is both responsible and profoundly inspiring. As the passage of 3 Atlas continues, we are invited to watch, listen, and reflect, immersed in the gentle unfolding of cosmic events, aware that every observation brings new insight. The universe moves with quiet majesty, and through thoughtful attention, we gain not only knowledge but a deeper sense of our place within this intricate, interconnected system. The journey of 3 Atlas, now nearing the inner bounds of our solar system, continues to unfold before our eyes. Observers on Earth, instruments trained across the spectrum of light and energy, follow its passage with a mixture of meticulous attention and quiet curiosity. From distant observatories perched atop mountain peaks to powerful space telescopes orbiting in the calm vacuum beyond our atmosphere, the collective gaze of humanity is focused on this singular interstellar visitor. The path of 3 Atlas is no longer a simple line traced across a sky map. It is a living story of motion, energy, and evolving structure, demanding both patience and precision to comprehend. Tracking the evolving trajectory of such a comet is a delicate enterprise. Each observation, each measurement of its position and velocity, contributes to a more accurate understanding of its orbit and the subtle forces acting upon it. Small perturbations, almost imperceptible against the vast canvas of space, can accumulate over time, slightly shifting the path and orientation of its elongated body. These minute adjustments are critical, for they help scientists anticipate when and how the comet will reach perihelion, when it will make its closest approach to the Sun, and how its tail and coma may respond to the increasing intensity of solar radiation. The instruments now involved in this cosmic observation are as varied as they are sophisticated. The James Webb Space Telescope, with its infrared sensitivity, allows us to peer through the dust and gas surrounding 3 Atlas, revealing the composition of its coma and the hidden structures within. Ground-based observatories, such as the Gemini North and Gemini South telescopes, provide optical imagery with astonishing clarity, capturing subtle shifts in brightness, shape, and hue. Each piece of data complements the others, creating a layered, multi-dimensional portrait of an interstellar visitor as it interacts with our solar environment. Continuous monitoring is essential because 3 Atlas is not a static object. Its nucleus, though solid, is cloaked in a halo of gas and dust that responds dynamically to the sun's radiation and solar wind. The coma expands, shifts, and subtly pulsates, while the tail stretches and reshapes itself with each passing hour. By observing these changes in real time, astronomers can refine their models, better predict the behavior of similar interstellar objects in the future, and understand the nuanced physics of plasma, gas, and dust in extreme conditions. The observations themselves become part of a larger experiment, a living record of an object that has traveled across light years of space to reach our corner of the galaxy. The importance of these continuous studies cannot be overstated. Unlike comets originating from the familiar confines of our solar system, 3 Atlas brings with it the chemical and physical signatures of distant stellar neighborhoods. Its unusual composition, dominated by carbon dioxide and enriched with nickel, provides rare insight into the diversity of materials that populate the galaxy. Every spectral line measured, every subtle shift in light intensity, adds a brushstroke to a broader picture, one that may illuminate the formation histories of distant systems, the processes shaping interstellar matter, and perhaps even the mechanisms of plasma behavior under extraordinary conditions. Observing this comet also reminds us of the value of patience in science. There is no need to rush toward conclusions, no necessity to yield to speculation or sensationalism. The quiet, meticulous accumulation of data is itself a story, a narrative of human curiosity aligned with the universe's gentle, expansive rhythms. As each observation is made, the comet slowly reveals its secrets, not in dramatic gestures, but through subtle variations in light, color, and structure. This approach, calm and methodical, aligns perfectly with the reflective nature of our pre-sleep documentary, inviting viewers to absorb, imagine, and contemplate rather than be startled or hurried. From a practical standpoint, continuous monitoring also allows for preparedness. Should unexpected interactions occur, changes in outgassing rates, variations in tail structure, or unusual electromagnetic activity, scientists are ready to observe, record, and analyze. These precautions underscore the importance of vigilance in astronomy. While 3 Atlas poses no immediate threat, its study offers a natural laboratory for understanding interactions between interstellar matter and the solar environment, with implications that may extend even to Earth's technological and geophysical systems. Beyond the scientific rigor, there is a deeply human dimension to these observations. Watching a solitary interstellar visitor glide silently past our sun evokes a sense of wonder and humility. It reminds us that our planet, our instruments, and our understanding are part of a broader cosmic context. The comet's passage is a quiet demonstration of interstellar interconnectedness, a visual and energetic bridge linking distant stars, the solar system, and our observational capacity. Each data point, each telescope image, is a testament to human ingenuity, reaching out to comprehend phenomena that have traveled millions of years to reach us. In the coming months, the observational campaign will intensify. Coordinated efforts among multiple observatories will ensure that 3 Atlas is followed from multiple perspectives, across varying wavelengths and temporal intervals. Infrared studies will continue to map the hidden structure of its coma. Optical telescopes will track tail morphology and brightness fluctuations. Radio instruments may even capture subtle electromagnetic emissions emanating from the plasma environment. Together, these datasets promise a comprehensive understanding of both its current behavior and the broader principles governing interstellar comets. The journey of observation is in itself a narrative, a tale of patience, curiosity, and the quiet thrill of discovery. By methodically documenting 3 Atlas's passage, scientists are not merely cataloguing an interstellar visitor. They are engaging with a story that spans both space and time, connecting humanity's gaze with a traveler from across the galaxy. It is an invitation to contemplate the cosmos with calm attention, to appreciate the subtle complexity of the universe, and to embrace the ongoing journey of learning without urgency or distraction. Even as we continue to record and analyze, the comet reminds us of a deeper principle, that the universe does not unfold in a single dramatic act, but rather in a sequence of gentle revelations. Each moment of observation is a quiet testament to the patient unfolding of knowledge, where the interplay of light, matter, and energy gradually illuminates patterns otherwise invisible. In this sense, the act of monitoring 3 Atlas is not only a scientific endeavor, but also a contemplative experience, one that aligns beautifully with the reflective spirit of a pre-sleep documentary narrative. Thus, as instruments across the globe and in space continue their silent vigil, we are offered a unique opportunity to witness the unfolding story of an interstellar wanderer in real time, to see how it reacts, transforms, and interacts with the solar environment, to understand, incrementally and patiently, the nature of a visitor that is both alien in origin and yet intimately connected to the physical laws that govern our own corner of the galaxy. And through this quiet observation, we gain not just knowledge, but a renewed sense of wonder, a reminder that even in the vastness of space, deliberate attention and curiosity allow us to participate in the ongoing narrative of the cosmos. While careful observation and continuous monitoring provide the foundation for understanding 3 Atlas, it is equally important to maintain a balanced perspective. The vast distances, the subtle interactions, and the delicate dynamics of this interstellar visitor naturally provoke curiosity, yet curiosity must be tempered with measured reflection. The universe, while full of phenomena that may initially appear startling, is not a stage for alarm, but a canvas for thoughtful inquiry. In the quiet hours of study, scientists and observers alike are reminded that not every unusual event signals danger or disruption. Historical records show that comets have passed through the inner solar system countless times, most leaving no discernible mark on planetary behavior or human life. 3 Atlas, despite its unusual composition and velocity, is no exception. Its presence invites attention, yes, but not hysteria. The gentle accumulation of data, the meticulous recording of electromagnetic activity, tail formation, and coma expansion all emphasize the process of understanding rather than fear. This measured approach reflects a core principle of scientific observation: inquiry without speculation. While it is natural to wonder whether this interstellar traveler could provoke solar disturbances or even affect Earth, the evidence-based perspective encourages restraint. Observations are interpreted within the framework of known physics, guided by careful modeling, and informed by previous encounters with comets and interstellar objects. Curiosity is encouraged, but it is curiosity grounded in reason and evidence, a curiosity that leads to deeper insight rather than anxiety. In practice, this balance manifests in the way data is shared and discussed. Astronomers communicate their findings with precision, noting both certainty and uncertainty. Terms are chosen deliberately. Words like possible, likely, and observed convey the nuanced nature of scientific understanding. By doing so, they invite engagement without sensationalism, allowing the public to appreciate the significance of 3 Atlas without feeling overwhelmed by hypothetical risks or dramatic interpretations. The visual and conceptual imagination of the observer is another tool in this balanced perspective. Envisioning the comet's glowing coma, the gently waving tail, or the ripples of dusty plasma offers a way to connect with the cosmic narrative on a personal level. Such imagery encourages wonder and contemplation, reminding viewers that beauty and complexity in space can be appreciated even without immediate consequence or danger. The story of 3 Atlas is as much about connection as it is about observation, linking distant celestial bodies to human curiosity in a harmonious, reflective experience. Maintaining calm is particularly important when interpreting the comet's unusual chemical composition and electromagnetic properties. The dominance of carbon dioxide, the enrichment of nickel, and the soft reddish hue are scientifically significant, yet they are not harbingers of catastrophe. Instead, they provide a rare opportunity to examine the diversity of interstellar matter, to understand the processes shaping objects that originate far beyond our solar system. Each detail contributes to a narrative that is intricate, fascinating, and profoundly enlightening, without demanding alarm. This approach also extends to the consideration of potential Earth impacts or solar interactions. While speculative connections may exist, the careful, evidence-based monitoring of solar activity, geomagnetic readings, and historical precedents provides context and perspective. Observers are invited to explore what-ifs within a framework of logic and measured expectation. The cosmos is vast, but our understanding grows incrementally, and each discovery enhances appreciation rather than anxiety. Ultimately, Section 8.2 is a reminder that engagement with the universe can be both thoughtful and serene. 3 Atlas is a messenger of curiosity, carrying the story of distant stellar systems, unique chemical processes, and the subtle interplay of energy and matter across space. By approaching its study with calm attention, avoiding hasty conclusions, and embracing the wonder inherent in discovery, viewers and scientists alike can experience a profound connection to the universe without the burden of fear. The balanced perspective fosters reflection, allowing one to move from data to insight, from observation to understanding. It is a gentle invitation to consider the rhythms of interstellar travel, the patterns of plasma and dust, and the intricate choreography of gravitational and electromagnetic forces, all without feeling rushed or pressured. In this quiet, considered approach, 3 Atlas becomes more than an object of scientific study. It becomes a companion in contemplation, guiding the observer through a universe both vast and intimately interconnected. As we hold this perspective, curiosity is nurtured rather than overwhelmed, wonder is encouraged rather than diminished, and the mind is free to explore the rich tapestry of space in a measured, reflective way. This philosophy leads naturally into the final chapter of our journey, where we will pause to consider the broader implications of 3 Atlas's voyage, its place in the cosmos, and the lessons it offers for both science and human reflection. As we conclude this journey through the mysterious path of 3 Atlas, it is fitting to pause and reflect on the broader story it tells, a story of cosmic interconnectedness, subtle forces, and the quiet grandeur of interstellar travel. The voyage of this lone visitor, originating far beyond our solar system, reminds us that the universe is not a collection of isolated objects, but a vast, interwoven tapestry of matter, energy, and motion. Each comet, planet, and star contributes a thread to this intricate design, and through observation, we begin to discern the patterns that tie distant regions of space together. In contemplating the journey of 3 Atlas, we are invited to adopt a perspective that is both scientific and meditative. Consider its passage through the solar system, moving at tremendous speed, yet leaving an impact that is subtle, measured, and detectable only through careful observation. Its enormous coma, the delicate dance of its tail, the unusual chemical composition, and the soft red hue, all these elements speak to a universe in which phenomena operate on scales that challenge our intuition, yet are governed by consistent laws and patterns. The elegance lies in their subtlety, in the quiet unfolding of events that are at once observable and profoundly mysterious. This reflection extends to our own place within the cosmos. Observing 3 Atlas encourages an awareness of scale, both temporal and spatial. We are reminded of how small our planet is relative to the solar system, how fleeting human time is compared to the ages traversed by interstellar travelers, and yet how our curiosity and careful attention allow us to engage meaningfully with these distant phenomena. Through this lens, the act of observation itself becomes a bridge, connecting human experience to the vast, intricate processes at work across light years of space. The story of 3 Atlas also exemplifies the value of patience and humility in scientific inquiry. Each measurement, each captured image, each spectral reading contributes to a growing understanding, yet always within the context of uncertainty. Space is full of surprises, and interstellar objects carry histories that may never be fully known. By accepting the limits of current knowledge while remaining open to discovery, we cultivate a mindset that balances curiosity with reverence, a way of thinking that is as much about the journey of understanding as it is about the facts themselves. Quiet contemplation of this interstellar visitor invites a kind of gentle wonder that is rarely found in daily life. Visualize the slowly expanding halo of dust and gas, the faint reddish glow, the silent waves of plasma rippling outward. These are phenomena that exist beyond immediate human perception, yet their presence can be appreciated through imagination and careful study. There is a rhythm to this contemplation, a cadence that mirrors the slow, deliberate movement of the comet itself. It is a rhythm that fosters calm, encourages reflection, and nurtures a sense of connectedness to the universe. As we draw this documentary to a close, the journey of 3 Atlas leaves us with a sense of both awe and intimacy. Though it is a visitor from afar, unbound by our solar system, it engages with familiar cosmic forces in ways that reveal the unity of physical laws across the galaxy. Its voyage is at once extraordinary and deeply resonant, a reminder that the universe operates in patterns and that even the most distant phenomena can touch the human mind and imagination. Ultimately, the story of 3 Atlas is an invitation. It asks us to watch, to learn, and to ponder the delicate interplay of matter, energy, and time across vast distances. It encourages us to embrace observation with calm curiosity, to appreciate the beauty of subtle forces, and to cultivate a quiet wonder for the cosmos. In this sense, the journey is not merely about the comet itself, but about our relationship to the universe. A gentle reminder that even in the vast emptiness of space, connection and understanding are possible. In these closing moments, we are left with a calm sense of curiosity and reflection. The comet continues its path, indifferent to our gaze, yet offering insights to those who observe with care and attention. Its presence is fleeting, yet its story lingers, an enduring testament to the beauty of discovery, the richness of cosmic patterns, and the serene majesty of interstellar travel. As 3 Atlas drifts onward into the darkness, we carry with us a deeper appreciation for the intricate and interconnected universe we inhabit, a universe full of mysteries waiting to be observed, contemplated, and understood.